The same Eddy who sent me one or two other sets also sent me one of these, which we're going to use as a donor. And this is a Communicator NI440DX, which was an LCL offering. So it doesn't say LCL on it, but it is the LCL Communicator NI440DX, which uses a Serpent UK 4000 chassis from Mickey Industries. Who would call their business Mickey Industries? It's like LG, isn't it? Lucky Gold Star, but they don't call themselves Lucky Gold Star in this end of the world. Because you'd think, well, you'd be lucky for it to work. People would make that joke like they did with Hyundai, high and dry, you know. So people do take the Michael on these, some of these, shall we say, non-UK names. Get rid of these self-tapper screws out of this radio. Now, in 1983, we did quite a lot of tests on CB radios, which weren't technical. They were the panel of users. And we sent the same radios around a dozen people, and they kept them for a week, and then they filled in a form with different things. And this came out the best of the best. The Communicator NI440DX was deemed to be the best radio on the market, and yet I get comments taking the Michael Mickey Industries out of these radios. So we're going to do this one, and because of Eddy's kindness, we've got a knob to put on this, which we didn't have before, so it's been sat on my shelf for about 3 years. The reason we can't do Eddy's one is because on Eddy's one, the socket's missing, and that's it. I'm not doing any set which has got the power socket missing. As far as that, if it's supposed to have a power socket, it's got to have a power socket. So, we'll open this up. This obviously is, good grief, how much wire's in that? Could run your speakers to the moon and back. And this, of course, looks right botch. I ought to really have opened this up before getting excited about it, in case it isn't doable. Okay, well, oh, it's got somebody's name on here. This is fun. Perhaps I can sell it them back. Wirebender, July 1987. Is he the one who bent all the wires in it? Isn't that lovely when you get that? And as you can see, it says UK 4000 on the printed circuit board. So clearly the Serpent UK 4000 was the actual set which it was supposed to use this chassis. There's two versions of the LCL Communicator. One has a yellowish meter, and I've got a sneaking suspicion that I felt was the better one of the two. So we will unsolder, and I'm going to see, because I've never thought about the technical side of these before, because they're quite an old-fashioned circuit, and that doesn't mean they're rubbish, even if people say they are. They don't have a clever IF subsystem chip. So whereas most UK FM radios do, these don't. So they use a quadrature detector and some more basic rudimentary electronics. So they're very, very difficult to set up. And this is, I think, what the killer is. That very few people have actually got one of these, which is set up properly. And as I'm talking, I'm looking at things which are tired. I don't know whether that capacitor's looking iffy, but we'll look into that. But I found these to be reliable and them to work. What on earth's happened here? It's like all the wires to the mic socket. I wonder if somebody's had a Roger Bleep in there and then they've had a brainwave and realised that they're pointless. So with that, I can't take the front off this. This is one of the killers, isn't it? Because we don't want to take the socket off. I'll put the knobs through the dishwasher, including Eddy's, and I'm not quite sure why that meter's like that. Yeah, we'll see what happens. So I'll get these in the dishwasher. We'll carry on with the repairs and video and all that. I happen to have got some of these power leads still, and to be honest, we don't want all this wire, so we'll start by cutting that there, and the rest can go in the vertical filing cabinet. So will we get 4 watts out of it? Will we get decent sensitivity? And so on. Now I've gone to the trouble and expense of ordering another signal generator for our other bench. We have, on bench 4, we have an HP signal generator. I've shown you on 1 or 2 occasions doing things with that. And I've bought another HP signal generator, not quite the same model, and the plan is that we're going to combine both the signals so that we can do selectivity tests, and that is adjacent channel rejection. So you have the one signal generator on one channel, you have the other signal generator on another channel. You take some readings, then with a mathematical formula, which I will have to look up, you can come to how many decibels of rejection that a given radio has. And so that is then the true bleed over thing. Nobody can argue that is the truth. Because there's a lot of myths and legends, always has been in CB. So I thought I'll go to the trouble and expense of doing that. And then when people go to me, oh, they're rubbish, those are, they get bleed over, I can give them the figures and either agree with them or prove otherwise. So I'll get that speaker off there and we'll get on with it. This is our original report in 1983 on the Communicator NI440DX, and we gave it 86% on transmit clarity, and 84% on receive clarity, 82% on squelch, 70% ease of controls, 82% appearance and layout, sensitivity 74%, 0.5 microvolts, and selectivity we gave 60, so it wasn't that hot and it was greater than 45 decibels. Features availability 4%, and there we go. So the overall test result was 77.75. So that's what we thought in 83, but it came out to be one of the top sets. The first thing we need to do is to put a suitable plug into the back of the radio, and this is the square type power lead. If I remember rightly, we've still got to shave a bit off this because it isn't quite the right one. And this is the Workman CB2R. Workman CB2R. I did look into having a Workman account, but you need to spend about £7 grand of time with them, and I didn't fancy doing that. So, with that said, the pins on the connector are very, very slightly offset. So what I tend to do, if I can find the knife, tell you what, I think they're all thieves in this prison. Anyway, I'm sure it doesn't fit properly, so we'll just see without breaking anything. Now I'll go and shave a bit of that off. Okay, so we'll go. So I've now plugged the thing in, and we'll connect this up and see what happens. It's what you'd call a standard microphone pin out. It's a 4-pin mic plug, and it uses the Cybernet type of wiring. And this radio does not need a receive wire because it has a relay. And when these were new 37 years ago, 38 years ago, I thought, fancy putting a relay in a two-way radio, that's going to be really unreliable. And to be honest, most relays in these in any CBs haven't proven to be that bad. But there's one or two I have changed. You know, the DNT ones and the oh dear, that chassis used in the Alba Mobile which is also used in the Eurosonic. Eurosonic 1 and Eurosonic 2. I had to import some from the United States, even though the Japanese relays are like £16 each, because otherwise to put a standard relay in and have to wire lots of little pins on and kind of fit it into the printed circuit board to fit, the time cost of that was greater than a normal relay plus the time fitting it. So we'll make sure this is in high power mode, which it is, and we'll plug this into the test instruments. I wonder when this was last powered up, because I've had it on the shelf since 2014, and I'd have bought it in a batch of scrap stuff, no doubt, off eBay. You know the kind of thing, there's somebody's got a CB on eBay, and it's just what you want. You haven't got one of those, but they've got another 5, and so you end up having to buy the whole batch, and then you end up with duplicates, shall we say, which we can sell on, but okay. So extension speaker is that one. I worry about improving all this if and when we get the radio to work. This might be the one we can't get to work. So switch the power supply on. Yeah, right, well, we've got a bar out on the display, or 2. So guess the channel. 13, 15, 16, 17, 18, 19, 20. So, CB mode. Yeah, everything's loose. It's been got at, hasn't it? Channel 9 off, so volume, squelch, RF gain to full, tone to high. We'll plug a mic in. How can I put the wrong mic in? Can I put the wrong mic in? I cannot put the wrong mic in. The radio's just gone straight into transmit. That must be not the right mic, because that's the right mic, which is still in its packet. Well, there's one thing it does, and that's transmit. I can't hear anything on receive. So the first thing I'm going to do is we'll put this into PA. Hello? Well, that says PA, and that says extension speaker. Hello? Wallow. Okay, so we'll put it back into there. Testing 1 2, testing 1 2. Testing 1 2 3 4 5 5 4 3 2 1. So it's working on PA, so that's a good sign. For some reason it's putting the received audio through that socket. I expect somebody's got all that around their neck. Anyway, we'll run it on the PA socket just for now. It's clearly receiving something. I've not even set the signal generator. So we'll put picture in picture on, and then we can both look at the signal generator and the power meter. So, power it up, it's doing more than 3 watts. It's doing 3.2. So, if we get our information here, so I've got TX1, TX2, TX3, TX4, TX5, TX6, and that looks to be it. TX1, TX2, TX3, TX4, I can't even see a core in there. So it's 3.2 is the maximum we're going to get with a hot set. Oh, right. Let's see what it's doing on low power. So we'll select low power. Is that the switch on the back? It probably is. And the answer is absolutely nothing. About 50 milliwatts, so there's a malfunction on the low power part of the circuit. So let's have a look at, oh no, it's power meter adjust. I'm on the wrong one. What a wally. Low power adjust is in fact that one. And we have about 380 milliwatts there, so that's now fine. So go back to the other one, which I've now messed up. That was the meter. I can't read my own writing on the service notes. So we always have it saying 4 even if it isn't. And then we need to look into deviation. So that's going to be VR3 down there, which it is there. Looks about right. Wallow. Just to take that off. Wallow. It's a bit quiet. I think we've got a dirty preset there. That's waggled it around a bit. Let's try it at that. Wallow. Wallow. Just a bit quiet. Let's try it at that. Wallow. That's now a bit loud. Wallow. Let's go back on the thing. Doesn't help with these being on the side. Let's try it at that. Wallow. Yeah, that's about there. It's a bit of a funny balance that, because I like it to average 2 to 2.2 and the absolute maximum would be 2.5. And this is averaging round the 2 whatever you do, but the absolute maximum at 2.5. So anyway, we'll see how it goes. So that's the transmit done so far. We will look into what it says on the spectrum analyzer later on. But the receive's the clever bit on these sets, which really takes some doing. So we'll just set the frequency counter, because the frequency counter, the signal generator. I'll tell you what we haven't done. We haven't done the transmit frequency. So we'll just go to the other camera. All the time I've been talking to you, we've been looking at the wrong meter. I've got it on the wrong camera. Sorry about that. So here we are with the, we'll go back. Low power, about 350 milliwatts. High power, 3.2, something like that. Deviation, low, maximum 2.5. So now we'll do frequency. So it should be 2779125. So it's still just about in spec, and it's the crystal trimmer. It's the one just there, 10.24. There we go, 2779125. The other trimmer is for the VCO, so that wants keeping off. That's the transmit VCO. So you'd want to monitor pin 17 of the LC7137 on receive for check for 4 volts, adjust L1, and then CT1 check for 4 volts. I have no reason to do that. So radio's working on channel 1 and 40. So we're on frequency, so now we'll go back to receive. And we're listening to 0.3 of a microvolt. So we'll see what the synad figure is. And I must say the radio sounds awful. For 12 decibel synad. At the moment, as it stands, it is a pretty awful 1.1 for 12 decibel synad, 1.1 microvolts. So that needs to improve dramatically, and no doubt it will. So we'll start by, I was going to say we'll start by doing the detector, but there isn't, for what there is, it's this one. So I've got S9 on the test set, and we'll now look at the oscilloscope. So that's the detector. And that was slightly out. So now we'll go over to the synad meter. We'll start doing a proper tune on it. So receive 1. Let's just turn that down a bit. It's got about 4 dB on the synad meter. Oh look, that's come up, hasn't it? One, 2, 3. Four, hidden by some tape. 5. Six. Drop that down a bit. 7. Now I'll go through all those again. One, two, three, four, 5, 6, 7. And we'll check the detector again. But it's still a bit funny until it gets to 1 microvolt. It's all right down at 0.4, but between 0.5 and 1, the radio is funny. So I think we need to check some of these, looking for quality as well as best outcome. It's that one. But now we'll try again. I'll just check those N2 again. Now it's not funny. So what's it now doing for 12 decibel cyanide? Oh! It's now doing 0.27. Wow. But you see what a faff that was to tune. Right, now we'll go to this S meter. We should have S9 on it. We've got above S9, so what do we need to adjust for that? It's the preset just here. So that's S9 set. What else have we got to do? Oh, we'll look at the squelch. So for a start, we'll put the squelch up to full. We'll see when that comes in, because what I want is for that squelch to come in at 100 microvolts. So we're parked at 0.3 of a microvolt, 1, 3, 10, 30, 100, and it's come in, but it's just disappeared off again. So it's right on the verge. So we just need to just pop that up a fraction, whichever way up is. Now that's how it is on full. That's a minimum. So it's, in rather than being 100 microvolts, it's about 120 microvolts on full, which is a little bit strong for me, but that's the best we can get. So at the other end, we'll turn the signal generator off and park it once again at 0.3. We'll turn the squelch down. Again, that control's a bit noisy, and they're a sealed type, which makes them awkward to clean. Work it around a bit. That seems to be its threshold, so switch the signal generator back on, and let's see when it's coming in. So that's a bit harsh at 1 microvolt. So I'll have another go, see if I can just set it a bit finer. See if that's any better. Yeah, it's coming in about 0.3. Yeah, we should be alright at that. But it's not helping that it's a little bit dirty, and with use that'll actually sort itself out. They're a sealed type of control, and you can't get the cleaner inside these. I mean, ultimately, I suppose you could drill a hole in the side of the control, but then you've got the possibility of ruining it. So we'd better leave it as it is. So one or two remedial things I need to do is to sort out why the wiring has gone how it has. But at the moment, and I'll tell you what, we'll write this down. We'll write this result down for that synad meter. So go back to that. So for 20 dB synad, 12 dB synad, and 10 dB synad. So what have we got? Well, there's 20. I can hardly believe this. It's 0. I've got it to 0.47 microvolts. For 12, we'll change scales. Yeah. It's 0.3, and then for 10, .27 microvolts. And if you remember, when we first tried this before I did the tuning, it was 1.1. So if you listen to 1.1 microvolts, that's 1.1, which is now something like 18 decibels synad. It isn't off the clock like some sets are. The receiver doesn't start picking up till about 0.15 microvolt, but it's absolutely excellent as far as I'm concerned. But unless you've got that synad meter and an oscilloscope and a really good attenuator on your signal generator, you cannot set these up. And I reckon I can set these up better than what they could at the factory, because I reckon we've got better gear here. But of course it's 38 years later. Now what would be nice is to get a little bit more power out of it. So we'll go back to the power meter. I don't think it's going to happen. I'll just go through these once again. 3.2 when warm. What we'll do, we'll look at what the spectrum analyzer has to say about it. Okay, so that's in the centre, and it is. So let's have a look up the scale. There's our harmonic. That's our 50 odd meg one. There's a coil there. It's things like the coil on the back here that can affect that. I've got to just make sure that that's not misshapen. Now I've just touched that and look where it's gone to, and you know what it was before. So now we'll go back to our fundamental. Fantastic. So just touching that springy bit of coil on the back of the error socket has knocked out that harmonic to next to nothing. But 3.2 watts is about what we're going to get. I'm just betting a lot of these new sets which won't even do that, you know, doing 2.7 flat out. So there we are. So the only anomaly now is the wiring of this. So I'll bring in a scrap chassis. I'll have a look at that display, but I really don't care an iota about that. It doesn't affect the radio at all. Right, well, we've put the case on. It's nice and worn, isn't it? And we've got... It's now wired to the extension speaker. Works in the extension speaker socket. When we switch it to PA... Testing 1 2.
1 2 1 2.
It's working in the PA socket. When we switch back to CB, it isn't coming out of the PA socket. So everything's now the right way around. I just looked at another chassis and saw what they'd done there. Right, so I'll take it off back onto its internal speaker, and we'll take it off the test instrument. Plug it into the aerial. See if we can hear anything. There's only one bar out on the display. I say it doesn't matter to me an iota. $19 a Roger. Right, well, we'll leave it there. Sat on 19. I think the install is, what time is it? About 1:30. Right, we're doing on the air test with this, and we'll see whether it actually works as well as it does on the bench. Thank you for watching the LCL Communicators NI440DX late version.